Dear colleagues, ladies and gentlemen, let me introduce you our keynote speaker, Professor Pietro Ducange, from Smart Engineering Solutions and Technologies Research Center and eCampus University from Novedrate, Italy. Professor Ducange will speak about social sensing and sentiment analysis, and he will try to exploit problems and conditions of online social networks as source of informations. Very shortly about professor's CV and research activities. Pietro Ducange received master degree in computer engineering and Ph.D. in information engineering from the University of Pisa, Italy, in 2005 and 2009, respectively. From May 2014, Pietro Ducange has been associate professor at the eCampus University. He teaches computer architecture, operating system, components, artificial intelligence, and data mining. He is director of the Smart Engineering Solutions and Technologies Research Center and the coordinator of Business and Computational Intelligence Research Group at the same university. Since September 2014, Professor Ducange has been adjunct professor at the University of Pisa, where he is also member of Data Science and Engineering Laboratory of the Department of Information Engineering. His main research interests include evolutionary fuzzy systems, big data mining, social sensing, and sentiment analysis, as well as multi-criteria optimization. He has been involved in a number of research and development projects in which data mining and computational intelligence have been successfully employed. He is co-author of more than 40 papers in international journals and conference proceedings. He has served at several program committees at the international conferences. Currently, he serves the Soft Computing Springer Journal as associate editor in methodologies and application areas. Please, Professor Ducange.
Thank you very much, Professor Martinovic. Thank you for inviting me. It's a pleasure to discuss with you this, I hope, quick talk regarding social network, social sensing, and sentiment analysis. Well, just to introduce myself and my institution, I am a professor at the eCampus University. This university is a private Italian distance learning university. We provide fully blended online courses, both in Italian and in English. We have 5 faculties and 22 courses, well, bachelor degree and master degree. Even though we are a distance learning university, we make research. Something it seems strange, but we also make research, and in 2006 I founded the smartest research center, Smart Engineering Solutions and Technologies. Well, our research center mainly make research in computer science, electronic communication, automation. And we also have a little group of basic and applied research in the field of mathematics, physics, and economy as well. The research center is affiliated with the engineering faculty. Our university is located in a very nice building, which was the training center of the IBM since the beginning of the 80s. And we are spread in Italy. We have 11 places where our university is spread. Okay, just for introduce myself and to thank them for allowing me to participate to this conference. This is the syllabus of my talk. I will introduce you social media and social networks, and we will discuss about the two main topics, namely the social sensing, and then based on social sensing I will show you sentiment analysis and some application of both social sensing and sentiment analysis. Hopefully I will show you 3 applications, and I'll give you some basics of text and data mining. I will try to give you in a quick way some element in order to allow you to understand what we did in our application. I will try to give some spots, no more. I will show application on traffic classification and social media marketing, and yesterday, thanks to my colleague from the University of Pisa, I had the opportunity of adding our last work, which regards the opinion mining on vaccination topics in Italy. Well, as you know, we are experiencing the Internet of Things, Internet of Everywhere, Internet of Everything era. We are everyone connected. Our smartphone is our second brain, maybe, third hand. Everyone is living in connection with the internet, in connection with other people, even younger or too young people. When we stay connected, we leave traces around us, both if you want or if we don't want to leave traces. You know, we have the big brother above us, controlling us more or less in every activity that we do with our smartphone, with our computer and tablets. There are some traces that we decided to leave and share. For example, when we post something on the Facebook, on Twitter, when we post our position, when we share images and video. Well, the social media, in order to give sometimes it's quite confusing to understand the difference between social media and social network. So I tried to clarify before to myself and then try to clarify you the difference between social media and social networks. Well, the social media is the content that we upload, and it's also the venue where we upload that content. For example, Facebook, Twitter, Google+, LinkedIn, and so on. It's interesting that it's the venue, it's the place. Well, when we start sharing, connecting, engaging with other people, we start with social networking. Well, at the end, we talk about Facebook as a social network, but actually we can say that Facebook is the social media and the social networking is the way of connecting with other people. In this picture I have extracted online, we can say there are a huge amount of social media, and there are different kinds of social media, not only for sharing photos or posting on write-down reviews on hotel or restaurant. We have social media for collaborating, for making networking, for discussing, for publishing, a huge amount. And you can give a look here and have the keywords of this social media. Actually, I don't know each one of these. Maybe I have practice with Facebook, Twitter, and LinkedIn, no more. I decided to give a look on the origin of social media and social networking. But I realized that in 1978, oh, please apologize for the color, I extract also this image from internet. In 1978, the first kind of social media were the bulletin board system, or BBS. It was a computer, set a computer server, running several software that allows users to connect to the system by using a terminal program. I don't know if you are familiar with Telnet. Long time ago, when I was at university, the first in the beginning of 2000 in my university, we had still the Telnet connection to the email. So once logged in, the user can perform some functions such as uploading and uploading software, reading and data, reading news, and even till exchanging email and messages with other people. So that was the first kind of social media and the first venue for social networking. Another interesting issue was that here you can see that in 1999 the first blog appeared. You know, blogs are web pages where people usually write down articles, share their images, and talk about some topic. You know, it's very famous now, the influencers that have their own blogs where they write down about some topic or issues. Well, the first blog appeared actually in 1997, and it was called Weblog. Then, a guy in 1999 transformed this, by joking, in Weblog. Weblog, Weblog. Then it remains the blog term, and so we start with blogging, and then the term blogging was coined. And from this timeline, you can see that Facebook appeared in 2004, Twitter in 2006, and then we have most recent famous social media such as Instagram in 2010, Pinterest, and Google Plus in 2011. And then other kind of social networks that I actually don't know what you can do with so many social media. This is a picture that also extracted online, and as you can see, the most famous and largely spread social media is Facebook. Almost 2 billion of users. Well, from Facebook we can extract interesting information, but we must looking for open pages and open profiles. Otherwise, Facebook has a very good privacy protection policy. I realized that yesterday that the second place is associated with Instagram. You know, Instagram is a social media where you can share mainly pictures and video, and even comments can be write down pictures. Then the most useful for me social media was Twitter. Well, in Twitter we are lucky because most of the information are public and we can extract them. I will discuss with you later how we extracted information on Twitter. So the application that I will show you will be mainly based on Twitter. Then we have LinkedIn, which is a business, as you know, a business-oriented social media with 500 million users. And also from LinkedIn, interesting information can be extracted, even though sometimes we have to pay if we want more information. This talk I will mainly consider a microblogging platform. As you know, Twitter and Facebook, Google Plus are a microblogging platform. We can write down not a so long text but usually the tests that we share on Facebook or Twitter are very compact and maybe contain very useful information. Indeed, people use intensely this platform to share their personal life, real life events, what happens around them. They discuss about topics, they assume a position on some issue, political position, something like that. So the social networking that can be built on social media allow people to create their own identity. And we share our identity with the world, with the internet, and we create a community. How do we act mainly on social media and social networks? Well, we mainly act in terms of status update messages. We call SUM. Well, here you can see my status update messages of yesterday. I shared with my friend that I was attending this conference, and then tomorrow, namely today, I will give this keynote. And I also share my position in OzzyJack Hotel, and I'll share the link of the conference. So most of my friends now knows where I am, what I'm doing, and some of them make some reaction, not so much. There were 8 people yesterday. Well, so the status update message usually include meta information such as timestamp, geographic coordinates, the name of user, the hashtag. You know, the hashtag create a sort of trend of the topic discussed on social media. Hashtag, I believe, was introduced by Twitter, but currently most of the social media exploits this element. We have mentions, we have comments. Well, and sometimes some, as in my case, regards information on a specific topic or related in a specific position or zone. Well, if we consider my post of yesterday, and someone was making an analysis of social network regarding the distribution of conference in Europe, they maybe will get my information and they will use that people are sharing their position in Osijek, where the SST conference was holding. And maybe if other people share this information, someone will be able to count or have an idea of how many people were attending this conference. So these are very important information that engineer, computer science engineer, programmers would like to exploit for their own benefit, and can also suggest enterprise to use for their business. And I'll show you something about this. In order to start to talk about social sensing, I would like to recall you social networks. Well, sensor networks, please apologize me. A sensor networks is a network where physical sensing devices are spread near a phenomena in an area where a phenomena must be measured, monitored. And we can have wireless sensor, wired sensor, different connection among them, different kind of protocols for communicating at different level, and so on. If we look at social networking, it's more or less the same. We have people transmitting information with their posts, with their status update message, and we have people that receive information by reading and by looking at the metadata that we share. So the idea is that we can consider the social network user as social or human sensors. Well, actually I was discussing yesterday with my colleague that the sensor is the smartphone, yes, but to another abstraction level, we are the sensors. And the status update messages and all the metadata are the sensor information. So social sensor give us indication regarding the life of people. So we want to exploit this huge amount of information for mining knowledge for be used in different applications. Obviously, social sensor can be integrated. We had experience in this, I will show you in the following, with classical sensors and creating an overall social and physical sensing network. There are several applications that can be done with social sensing, and I experienced the real-time traffic monitoring that I will discuss with you in some minutes, where we collect tweets from people and we try to have an idea regarding traffic situation in the Italian road network. And it works quite well. Other applications may regard smart buildings. For example, we can use information posted and shared on social network regarding the feeling in a room. For example, here, someone can write down, it's too hot, or it will be better to open a window. We can ask people also to share this information, even though they didn't have any idea about sharing this information. We can say, we did it at university, we say to students, well, since you often use your smartphone during classes, please sometimes write down something about your feeling in this room, and let us make some experiments regarding your feeling, temperature, humidity, and light, and so on. The social sensing has been deeply used also for estimate the level of damage after a natural disaster. Let's think about earthquake that we had in Italy, for example, in Umbria. And you know that Facebook has also a function in which a user can say, I'm okay, don't care. If you live in a zone where something happens, Facebook allows you to use a function where you can specify that you are okay, in order that your friends can know that everything is going well. Well, there's other applications, smart tourist, and outline of social behavior. And when we deal with the analysis of feedbacks about the satisfaction of a service or discovering trends in public emotions, we mainly talk about sentiment analysis and opinion mining. So when I used the social sensing for the traffic, it was not related with sentiment analysis. I just wanted to know if a traffic situation, was shared by people. If I want to know the opinion, the sentiment, the emotion, the mood expressed in a text, well, now I'm dealing with sentiment analysis. Sentiment analysis is a technology that is usually very adopted for several applications, and mainly it deals with the detection of the polarity in terms of positive, negative, neutral of a sentiment included in a text. There is also some much difficult strategy and algorithms that aim to identification of specific emotions such as hate, anger, joy, sadness. It's a very difficult task. I'm not involved in this activity. And then other task is to distinguish among objective and subjective tests. Also in this case I'm not involved. Well, I'm mainly involved in opinion mining, and opinion mining is a very challenging topic because also human experts may have problems, may disagree on the sentiment expressed in a text, deal with ambiguity, sarcasm, irony. That's very difficult. Indeed, we will see that the accuracy when we deal with opinion mining is much more lower than when we deal with the social sensing, for example, in the case of traffic. Just to have a quick idea, we stay in everywhere, we share with our smartphone, with our laptop, with our computer, our emotion. We leave our emotion on the internet, in the venue of our parallel life, let me say. And if we are able to collect all this information, write down softwares based on artificial intelligence, computational intelligence, natural language process, we can generate reports, we can generate alerts, we can generate a huge amount of summarized information that can be used for different applications. So the idea is to understand which is the level of the polarity towards a positive and negative position on a topic or on a situation. Which are the main application of sentiment analysis? Well, enterprise, which my business, may be interested in the analysis of their brand reputation. Let's imagine, for example, Armani, Gucci, big fashion enterprise company. Well, they are very interested in understanding if the brand reputation is going up or is going down. So collecting information from the social media channel or from unofficial channels, but they can be channels of private people, we can give them information about the reputation of their brand. And similarly, we have applied for a project in Tuscany where there are some enterprises which product clothes, and they would like to understand in advance, at least 6 months or 1 year, what will be the fashion trend in order to understand what to produce. So next summer, people will be happy to wear yellow t-shirts. So they will start to produce yellow t-shirt. This can be done by using sentiment analysis. Another interesting topic is the online dispute detection. You know, there is in this period, in this world of posting, expressing reviews, something like that, a new category of people is going to appear. It appeared already. These are the haters. People that hate other people and write down bad things against them. So it can be interesting to identify where haters are distributed, and in order to avoid problems. And in Italy we had some problems with young people that would be big problem due to haters. So it can be interesting to identify dispute and try to avoid any problem. Just to give a quick look on how to extract useful information from status update messages and metadata. Well, the text mining techniques are the methodologies that are often used for analyzing data, and these methods range from data mining, machine learning, statistics, natural language process, and so on. Well, the text mining consists in extracting automatically information and knowledge from unstructured text. Again, the main difficulty of these methodologies rely with the vagueness of natural language, the irony, the sarcasm, but The positive aspect is that now we have computer clusters, distributed computing, cloud. So we are lucky because we can analyze a huge amount of data and try to extract information even though we have a certain error associated to it. We experience it in analyzing by hand text extracted from tweet, and believe in me, it's very, very boring and very, very hard to read tweets in order to try to label texts. Text mining can be faced by using different approaches. Maybe the most famous is the Lexicon-based approach. I will give some words regarding this method, and data mining techniques, machine learning data mining techniques, and hybrid approaches. Well, the Lexicon-based approach mainly deal with using a predefined sentiment lexicon. Imagine a vocabulary where a huge amount of words have been collected, and to each word we can associate sentiment polarities and its degree of the polarity, strength value regarding the polarity. So let's suppose we have the word good as a positive polarity with a value equal to 0.9. And if we consider the word optimum, you have a positive degree polarity, and the value is, for example, 0.99, and so on. This lexicon can be used with statistical semantic networks, also considering data mining. The problem is that lexicon are usually used for general context without any bounds. For example, in the case of traffic classification, it was not a good idea to use lexicon based, because we don't care about good or bad. We're looking about traffic, queue, something like that. There are some lexicon that can be downloaded for free in different languages, and here I give you some indication if you're interested in them. Well, in order to work in context-related situation, we may use machine learning and data mining. Mainly we use supervised data mining methods, classification algorithms, which are supervised, which need supervised learning stage. We want to teach to the system how to recognize a polarity, but we need training set made of labeled tests. I mean, we have to give some examples in which texts are associated to positive, negative, or neutral polarity. And this is a bit boring. Very quick elements on data mining. You know, data mining is discovering interesting patterns and knowledge from a huge amount of data. So you have data. There's a very famous picture with this woman that wants to mine information on data, and this is the flow of data mining. Also, for people that are familiar with data mining, I know this picture from the Data Mining Concept and Techniques book. We start from a database, we sample, we select instances, we preprocess them, we transform them, and we generate models and patterns, and then we analyze and visualize the results. Data mining is mainly based on two kinds of models. Descriptive models, namely clustering, for example, which are models based on unsupervised learning and unlabeled data, and we use this mode for building a structure, for having an idea of the structure of the hidden knowledge behind the data. So, you know, by using clustering, we can know if groups can be found in our dataset. Well, in this work, in this talk, we are interested in predictive models, such as classification or regression algorithms, and these models exploit the parameters of the algorithm for giving future prediction. But in this case, we need a supervised learning stage, as I stated you before, and we need labeled data for training the models. The classification process, starts from an object, in our case, the status update message. We need to acquire them, to retrieve the object, to extract features, because our classification algorithm, works with numbers, not with pictures, nor with text. We need numbers. So we extract features, we redact feature, we can build different models, we can combine them, and then build a model for given prediction. Another different kind for evaluation models, this is the training test flow. We have data, we divide the data in training and test. Using the training set, we derive the models, estimate its accuracy, and then we evaluate the generalization capabilities by using the test set. Another approach is based on k-fold cross-validation. Basically, we repeat the previous flow k times, because we divide the data set into k-folds, and each time we change the testing set and the remaining block I use it as training set, and then we calculate k accuracy, and then we extract average value. There are several classification algorithms. This is a tree. It's not exhaustive. We have statistical and structural data. Among structural algorithms, we have rule-based, distance-based neural networks, and so on. The taxonomy of classification is very, very big. It's just a quick idea. And this is our text classification platform. We mainly base our activity on text classification, and then we interpret the classification in somewhere. We need to retrieve text, we need to elaborate text in order to extract features, and we need to classify text. This I must go very quick because I want to show the application. And usually we fetch text by using keywords and by using some API or writing down some crawler. But basically we use search criteria, keywords, time, location, hashtag, and so on. The raw text must be elaborated in order to extract the text, remove useless information, and so on. Once we have the text, we have to transform the text into number. So this is the classical approach based on bag of words representation. There are other approaches, but I'm showing you one of the most used. In practice, we transform the text of a sum in a list of tokens, and basically tokens can be words, like in this example. This a Twitter on vaccination, and in Italian, and here we divide it in tokens. This is a list of words which are tokens. Once we have tokens, we have to remove stop words. Stop words are words that are not useful for our classification. Articles, conjunction, prepositions, and also words that appear very often in a language or in a specific situation. So some of tokens here are removed here. So we have a list of relevant tokens. But in languages like Italian, Spanish, Portuguese, and other Latin language, I don't know what in Croatian, it's important to reduce words to root form. And this is the stemming procedure. So you can see here, vaccinato, vaccini can be transformed in vaccine. So from two tokens, we obtain one stem, which is vaccine. And so on. Not all the stems are interesting. Well, we must set up our system by following a supervised learning stage where we show a corpus of text, and from this corpus of training text we extract the relevant stems. So we must identify, suppose that someone gives us this set of relevant stems, we have to identify in our specific sum which are the relevant stems. So idiocy, cause will be eliminated because they are not among the list of relevant stem. We can identify automatically the relevant stem. Someone can give us the relevant stem. It depends. And finally, we need numbers. We need the feature representation as a vector of the text. So, for each relevant stem, for each sum, we have to build a vector with a number for each relevant stem. Let's suppose that we have f relevant stem. So we need a vector of f numbers. We put 0 in corresponding to the relevant stem that are not included in our tweet. And we put O1, binary representation, if the stem is associated or not, contained or is contained or not into the set of relevant stem, or with a weight. And I'll show you that there can be different kind of weights. It can be general weights for the entire corpus and specific weights of the specific sum. This is the entire text elaboration process. From starting from text, we arrive to numbers. Very quick, I want to show the application. The supervised learning stage is mainly need for identify the relevant stems, compute weights for the relevant stems, and identify the parameters of the supervised classification model. So to this aim, we need to collect training sums and then transform these training sums in order to obtain a set of relevant stems and associate to each relevant stem a weight. Details on how calculating weights can be found in the paper associated with this talk and also in other papers. This is very famous, the inverse document frequency. Well, finally, we obtain a set of relevant stems after, for example, a feature selection process, a classification model, and we embed this model into the final tool for the application. These are some advices, but you can read it in the paper on which tools use. Let's go to the application. I've been involved in a social sensing project in Smart City. It was called Smarty, and we exploit information collected in a city, such as parking information, environmental information provided by physical sensors, information from social network. And my task was to real-time identification of traffic situation by using Twitter stream. Again, this is the architecture that I showed before, and at the end we collected tweets from the Italian road networks, continuous collected tweets, and we classified the tweets in traffic related and not traffic related. If we detect more than 2 or 3 tweets associated to traffic, we give the traffic alert. In order to do so, we had to download a certain amount of training tweets, and we had to label by hand these tweets. So at the end, we identified 1,300 tweets, the half related with traffic situation and the other half related with non-traffic situation. And here we have some examples. We experimented several classification algorithms, and we realized that the supervector machine gives us the best accuracy on our training set, 95.75 accuracy, and also the precision, the recall, and the F-score, which are metrics specific for the binary classification, are related with true positive and false positive, are very high. So we embedded this classifier into our system, and we had a campaign which lasted some months for the project, 2 months, and we managed to identify traffic situation even before official traffic channels, for example, news and so on. This is the second application, which regards sentiment analysis in social media marketing. You know that enterprises often use different channels for promoting their business. Here we have the example of this hotel as a social media marketing channel on Facebook and on Instagram. We want to mine opinion on comments provided on posts that the social media manager put on these channels. So we want to continuously fetch comments on posts, to analyze comment and extract sentiment, and give alerts for negative comments. What the problem is that we need a model for a specific application. Let's imagine the hotel, or for example, a shop which sells clothes. Completely different models we need, because the comments may be different. And we don't want to label manually the training comments. So we must find a solution for getting free training, free of charge training comments. So my idea was, let's extract the training comments from already available labeled text. For example, I want to know if the comments are positive or negative. I can go on TripAdvisor and download some set of reviews. They are labeled with stars, and let's use them to classify comments. It works well. Reviewers can be used instead of labeled comments. Reviewers are already labeled. Okay, we consider that the labeling is correctly associated with the text. It is not true. But similarly, if we go on Amazon, we take some reviews regarding an item or a category of items, and we can use this review as training for the model for the comments. This is the example of a restaurant. We extracted 1,000 negative 1-2 stars reviewers and 1,000 positive reviews, and we also fetched 1,000 neutral posts, more or less by hand. I read a huge amount of reviews or comments in my life, so trust me, I have a dataset with a huge amount of neutral polarity that can be used in several contexts. Again, in this case, the supervector machine achieved the highest accuracy, but pay attention, it's a bit lower, because in this case we have 3 classes. There's an example of usage. It's a post of a restaurant. It's July the 1st, dinner for 2 connoisseurs, quail skewers with bread croutons. Quails are sort of birds, you know. And these are the comments that extracted below this post. And for example, I correctly recognize that in this case, 1, 2, 3, 4, 5, 6 comments, and 2 comments have been not correctly recognized. For example, the first comment, I'm salivating at the idea of eating quails. It is a positive comment, but my system said it's a neutral comment. Okay, we cannot find everything correct. The last one says, good food, even though I don't like quails and I eat potato salad and cheese. It was classified as negative, but I believe that it is a positive comment. You know, but maybe the system identified I don't like, so maybe move it towards negative polarity. The last application, just 5 minutes. It's very important because we have the problem in Italy of vaccination. Family are not vaccinating so much their child, and we have a problem. At the kindergarten, for example, my daughter goes to the kindergarten. She's 2.5 years old, and if you don't vaccinate your children, we reduce the effect of the vaccination of other people. So we want to analyze the vaccine-related tweets with a text mining approach, and we want to infer the public opinion of Twitter user about the vaccination topics. It is very important now in Italy, this topic. we consider 3 class classification problems in favor of vaccination, not in favor, and neutral. And I read a huge amount of tweets regarding vaccination, and it's very difficult for us, it's very difficult to decide if a post is positive, negative, or neutral. Very, very difficult. So we identified more or less 600 tweets, balanced data set, so the same number of tweets for each class, and we build a classifier, again super vector machine classifier, that in this case achieve a very low accuracy, 65%. But if you check on literature, the opinion mining in specific topics such as vaccination, the accuracy that can be reached is very low, not higher than 70%. We are around 65%. So once we build a classifier, we put our system online and we collect more or less 100,000 tweets, and especially we identify a huge amount of tweets during some social context related events. I'm finishing. For example, there was event number 9, Italian TV show report was focusing on vaccine causes controversy. So people start talking about it. Or fake vaccination news on some Italian city, and so on. The president of the Italian Republic signed the decree about the vaccination requirement in Italy. So in correspondence to these events, we have peaks of talking about vaccination. Most of the tweets are related with neutral, because people talk about vaccination, but not often they express opinion. But among the opinion, more or less half and half. The half are in favor, the other half is against. Yeah, I know it's very difficult to read this, but here we have the cumulative tweets. And at the end, in July, we summed all the tweets that we obtained in 10 months. Most of the tweets collected were regarding neutral. People talks about on Twitter vaccination, but more or less positive and negative, 20% or positive, 20% or negative, and 60% of neutral talking about it. Well, let me finish. I want to thank Michela Fazzolari who co-authored with me the paper Social Sensing and Sentiment Analysis that you can find in the proceeding of the conference. And you have a useful list of recent references that I found during summertime when I prepared this paper. And I must thank people from the University of Pisa. Most of the activities that have been discussed here have been carried out with them. So Professoressa Beatrice Lazzarini, Professor Francesco Marcelloni, Eleonora D'Andrea, which is one postdoc collaborator, and a student of the eCampus University was a very good student, Roberto, which developed the part of social media marketing. He was a very good student. So special thanks to Professor Martinez. Thank you very much for inviting me and for supporting me. Thank you.
Questions, please?
Do you have any question? I'm happy to answer.
I have only one short question. What are your main challenges regarding the real-time requirements for processing of
the real-time processing is not a problem. The main problem regards building the model, because we need the training data, and sometimes, especially in the case of opinion mining, it's very hard to retrieve this training data. Once we have the model, the use of streaming architecture, distributed streaming architecture, but in our case we use just web services on an enterprise service bus, and which provides the results of the query and of the classification. It's not a problem for real-time requirements. The problem is building model.
Yes. Thank you very much. Thank you again.
just a curiosity, how much is important to let's say the language beside or under a message, because
okay, a specific model is needed for a specific language, but I'm starting to work with text. I started in 2013, but I'm mainly involved in the data mining process and system design. But I know that there are some cross-language approaches for building models which are independent from text. And so I'm going to collaborating with people from the Italian National Research Council, which has a better experience in building cross-language models.
Thank you. Thank you again for a very interesting lecture.
Oh,
it is
thank you.
Small present for you and your certificate.
Oh, thank you very much.
Thank you.
You're welcome. Thank you again.
Time is over.